Okay, this is my first attempt to do one of these YouTube videos to show you how to do the quizzes. So let's go ahead and try to do quiz 29. Let's see if I can make this work. Okay, so first of all, this is okay, let's see. I'm going to have to do that. And okay, this is an XOR gate. So let's just remember how XOR works. If I have a 0, 0, 0, 1, 1, 0, 1, 1, XOR for zeros, it's only 1 if one of them is different. So this would be a 0, 1, 1, 0. So in this previous case, we have again 0, 0, 0, 1, 1, 0, 1, 1. And in this case, so because both of the inputs are knotted, we have to knot and then XOR. So 0, 0 would be 1, 1, and those are the same, so that's going to be 0. 0, 1 knotted would be 1, 0. Those are different, so that'll be a 1. 1, 0 are knotted, so it'd be 0, 1, and those are knotted, that'd be 1. 1, 1 are knotted, so it'd be 0, 0, and they're the same, so this is 0. So this actually just implements an XOR as well. Okay, let's go down here. 0, 0, 0, 1, 1, 0, 1, 1. So because the first element is knotted, 0, 1, and then we have an XOR. So we have 0, 0 would give you a 1, 0. Those are different, so that would give you a 1. 0, 1, the first one knotted would be a 1, 1, so that would give you a 0. 1, 0, first one knotted would be a 0, 0, so that would give you a 0. And then 1, 1 knotted would be 0, 0, so that would give you a 0 as well. And so this looks like remember, an OR gate would be 1 if all those would be 1, 0. So this is actually a NOR gate. Okay. The second one we have 0, 0, 0, 1, 1, 0, 1, 1. Okay. And the second element here is knotted. So 0, 0 would be 0, 1. And when we XOR that, that gives us a 1. 0, 1 would be 0, 0. And when we XOR that, that's going to give us a 0. And then 1, 0 would be a 1, 1. XOR that, that's going to give you a 0. And then 1, 1 would be 1, 0. And when we XOR that, that's going to be a 1. 1, 0 would be, when I do a 1, 0 XOR would be 1. Okay, so this guy is going to be, let's see if I did it right. I should have got the same result as above. So a 1, 1. Yeah, so I guess I did this one up here wrong, because a 1, 1 should have been a 0, 1, and that would have given me a 1 here. Okay, so this is actually 1, 0, 0, 1 is actually the opposite of that thing. So this should be an X NOR, and this gives us the same thing, so we'll have an X NOR. Sorry about that. Okay, so let's just go over here and do the truth table for this guy. 0, 0, 0, 1, 1, 0, 0, 0. And we're knotting both of those, and then we OR them together. So a 1, 1 ORed together gives us a 1. A 1, 0 ORed together gives us a 1. 0, 1 ORed together gives us a 1. And then a 1, 1. I'm sorry, this should have been a 1, 1. So a 0, 0 ORed together gives us a 0. So this is equal to a this would be a and gate negated. So that would be a NAND. Okay, and then here again 0, 0, 0, 1, 1, 0, 1, 1. Okay, when we invert the two, so 0, 0 gives us a 1, 1. We OR 1, 1 together, and that gives us 1, and then we NOT that, and that gives us a 0. A 0, 1, we NOT those, and we get a 1, 0. We OR those together, and that would give you a 1, and then we NOT that, and that gives us a 0. 1, 0 turns into 0, 1. We OR those together, and it gets a 1, and then we NOT that, and we get a 0. 1, 1 turns into 0, 0. We OR those together, and we get a 0, and then we NOT that, and we get a 1. All right, so this thing looks like an AND gate. Okay, this should have been AND. Okay, now on this one again, 0, 0, 0, 1, 1, 0, 1, 1. 0, 0 together, knotted, gives you a 1, 1. We AND 1 and 1 together, and we get a 1. A 0, 1 gives us 1, 0. We AND that together, and we get a 0. A 0, 1 gives us, or a 1, 0 gives us 0, 1. We AND those together, and we get a 0. And then 1, 1 gives us 0, 0. We AND that together, and we get a 0. And so this looks like a NOR gate. Okay, this should have been a NAND. All right, 0, 0, 0, 1, 1, 0, 1, 1. So 0, 0, knotted those, gives us a 1, 1. We AND that, we get a 1, then we knot it, we get a 0. A 1, 0, 1 gives us 1, 0. We AND 1 and 0, we get a 0. We knot it, we get a 1. 1, 0, knot both of those, we get a 0, 1. We AND those together, and we get a 0, and we knot it, we get a 1. A 1, 1 gives us a 0, 0. We AND those together, and we get a 0. We knot that, we get a 1. So this looks like an OR gate. Isn't this fun? 0, 0, 0, 1, 1, 0, 1, 1. All right, so 0, 0, we knot the first one, we get a 1, 0. We XOR that, we get a 1, and knot it, we get a 0. 0, 1 becomes 1, 1. We XOR that together, and we get a 0, and then we knot it, we get a 1. A 1, 0 becomes a 0, 0. XOR that together, we get a 0. We knot it, we get a 1. 1, 1 becomes a 0, 1. We XOR those together, and we get a 1. Knot it, and we get a 0. Oh, so this just looks like an XOR gate. And we can expect this would give us, we just invert the two roles, so this should also give us an XOR gate. And then this guy, 0, 0, 0, 1, 1, 0, 1, 1. So 0, 0, we knot those together, we get a 1, or knot both of those, we get a 1, 1. We XOR that, gives us a 0, and then we knot that, we get a 1. 0, 1 gives us a 1, 0. We XOR those together, we get a 1. We knot it, we get a 0. 1, 0, we knot those, we get a 0, 1. We XOR those together, we get a 1, and knot that, we get a 0. 1, 1 gives us 0, 0. XOR that together, we get a 0. Knot it, we get a 1. So this gives us X NOR. Okay, there's how we do problem 1.